Hi grade 10s, it's Ms. Thongaraj here. My last video was about finding the centroid of a triangle. Finding a centroid meant we had to find the medians and find out where the medians intersected. Today I'm going to make a second video, and today it's going to be about finding the circumcenter of a triangle. So let's look at a picture of what a circumcenter looks like. So here's a picture of a triangle, and in the middle of the triangle we have the circumcenter. In order to find the circumcenter, what we need to do is we need to find two perpendicular bisectors and find out where the perpendicular bisectors intersect. So if I'm looking for a bisector, it means I need to find the midpoint of one of the sides. And if it has to be a perpendicular bisector, then I need to find the slope of one side, and the perpendicular bisector will have a slope that is the negative reciprocal of the side's slope. So here is the example that we're going to try together. We want to find the circumcenter of the triangle with the vertices 3, 2, 1, 4, and 5, 4. And remember from the past picture that we just saw that we need to find the perpendicular bisectors and find out where those perpendicular bisectors intersect. So if you're looking for a bisector, it means you need to find midpoints. So let's first find the midpoint of the top of the triangle. So I'm going to find this midpoint right here. Now this point right here is 5, 4, and this point right here is 1, 4. To find the midpoint, I add up the x's and divide by 2. I add up the y's, divide by 2. So I need to do 1 plus 5 divided by 2. I have to do 4 plus 4 divided by 2. And that means that I'm going to end up with 1 plus 5 is 6. 6 divided by 2 is 3. 4 plus 4 is 8. 8 divided by 2 is 4. And that makes totally a lot of sense, because if this is 1, 4, this is 5, 4, right in the middle would be 3, 4. Now, so I found the bisector part. Now I want to find the perpendicular part. Now, this question is actually an easier question than most, because I know that the top of that triangle, we know that this right here is horizontal. It's horizontal because this y and this y are the same. It's not going up, it's not going down, it's staying level. It's staying at the exact same y's. And we know that perpendicular to horizontal is vertical. If I want to find perpendicular to horizontal, I need to find something that is vertical. So all I'm going to do is, instead of drawing a horizontal line through 3, 4, I'm going to draw a vertical line through 3, 4. I'll do that right now. And when I look at this, I can see that perpendicular to this horizontal line is a vertical line that's parallel with the y-axis, and it goes through x is equal to 3. So this line simply has equation x is equal to 3. If I want to know the equation of the top line, it would be y is equal to 4. If I want to find the line through here, it would be y is equal to 4, and perpendicular to that is x is equal to 3. That equation, that perpendicular bisector, was easy to find. The next one is going to be a little bit more challenging. What we need to do is we need to find the midpoint of a second side of my triangle. I need to find the slope of that side, and then I need to find a slope that is perpendicular to that. So let's do that right now. I'm going to use my midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. And I'm going to get that 1 plus 3 divided by 2, 4 plus 2 divided by 2. My midpoint is going to be 4 over 2, comma 6 over 2, which is equal to 2, comma 3. And that makes total sense. This point right here that's in the middle looks like the point 2, 3. We have found the midpoint. So remember, we need to find the perpendicular bisector. We found the bisector part. The midpoint, that is the point that bisects the side that goes from 1, 4 to 3, 2. We now need to worry about the perpendicular part of the question. So I know that when I'm looking at perpendicular, it means I need to find slopes. So I need to find the slope of this side, 1, 4 to 3, 2, and I'll do that right now. I've taken the points 1, 4 and 3, 2. I put them in a table. I'm finding the slope by checking the delta y, or how much the y's are changing, and the delta x's, how much the x's are changing, and my slope is going to be -2 over 2. My slope is -1 over 1. And I know that if I want to find the perpendicular bisector, that means the slope of the perpendicular bisector is going to be the negative reciprocal of this. So my slope won't be -1 over 1. My new slope will be +1 over 1. Negative reciprocal means instead of negative, it becomes plus, and 1 over 1, I flip that, but that's still 1 over 1. So that means that this perpendicular bisector is going to have a slope of 1 over 1. So now that I know the slope, I know I need to use the equation y is equal to mx plus b. I know I need to put in my slope, the slope that is perpendicular to the side. But remember, it's a perpendicular bisector, so I need to use the bisector part, which is the midpoint. I need to put my 2 here and my 3 here. And I want to find my b, so my b is going to be 3 minus 2. My b is equal to 1. So that means the equation of this perpendicular bisector is going to be y is equal to 1 over 1x is just 1x plus 1. Let's graph that perpendicular bisector up here on my grid so we can predict where the circumcenter should be. So I'm going to take my y is equal to 1x plus 1 and put it on my graph. 1x means it's jumping 1 each time. The plus 1 means it starts at 1. The y-intercept is plus 1. So here I am. It starts at plus 1 and it jumps 1 each time. Jumps 1 each time. So remember that the circumcenter is just where the two perpendicular bisectors intersect. And so this is really interesting because what you'll notice is that sometimes the circumcenter is not actually inside the triangle. This was, right here, this was the first perpendicular bisector. This was the second perpendicular bisector, so they actually intersect at 3, 4, which means that this triangle has a circumcenter that's not actually in the middle of the triangle. It happens to be a point on the outside of the triangle. So our circumcenter for this question is 3, 4, because that's where my two lines, that's where they intersect. Let's try one more example together. You're given 3 vertices, I've graphed it, and I want to find the perpendicular bisectors. And I know that when the two perpendicular bisectors intersect, that's a circumcenter. So let's pick 2 sides and let's find the midpoints of those 2 sides. So I'm going to find the midpoint of this side, and I'm going to find the midpoint of that side. Why don't you pause the video and find those 2 midpoints right now? I've found the 2 midpoints. I found the midpoint from that top side, and I found the midpoint from the bottom side. And I don't just want the midpoints, I want a perpendicular bisector. So I found the bisector parts. Midpoint means I'm bisecting. Now I need to find out the slopes that are perpendicular to the slopes of these sides. So I need to find the slope of this side. I need to find the slope of this side, because then I can easily find the slopes that are perpendicular to those slopes. I found the 2 slopes. I found the slope between -4, 1 and 4 minus 4, and that slope is -5 over 8. I found the slope between -4, 1 and 2, 4, and that slope is 3 over 6 or 1 over 2. So let's first deal with the perpendicular bisector from this point right here. So that means I need to look at this slope, which is negative 5 over 8. And I know that if it's perpendicular to negative 5 over 8, it's going to have to be not negative 5 over 8. It's going to have to change to plus 8 over 5. I'm going to use the equation y is equal to mx plus b. Y is equal to 8 over 5x plus b. And I know it's a perpendicular bisector, so I've got the perpendicular part, but I need to use the point for the midpoint so that it bisects. So I've got to use the point 0, negative 1.5. So I'm going to put the 0 here. I'm going to put the negative 1.5 here. So that's going to give me 8 over 5 times 0 plus b is equal to negative 1.5. 8 times 0 divided by 5, that just cancels out. So that means my b is equal to negative 1.5. If I want to keep fractions, this is just the same thing. It's negative 3 over 2. So that means my first perpendicular bisector is y is equal to 8 over 5x minus 3 over 2. I'm going to go ahead and draw that on my graph. I've taken that line, I've drawn it on my graph. And one thing that's interesting about perpendicular bisectors is that they're perpendicular, they go through the midpoint, but they don't necessarily go through the other vertex. See how that line doesn't touch the other vertex? And that's okay. Now what we want to do is we want to do the same process. We want to find the perpendicular bisector from here that goes this way. So we want to, I'm taking my ruler to show you, I want to find a perpendicular line, and I want to get the equation of that, and then I want to see where the two perpendicular bisectors intersect. So remember, we've already found the slope of that top line in the triangle. We know that slope is 1 over 2. If we want to make something perpendicular to it, it has to have slope negative 2 over 1. And I also need this line to go through the midpoint since it's a perpendicular bisector. So I need to add x is equal to minus 1 and y is equal to 2.5 into this equation here. And when I do my algebra, when I sub in my x and my y for my midpoint, I get that my b is equal to 0.5. So now I know that the equation of the other perpendicular bisector is y is equal to negative 2x plus 0.5. I'm going to go ahead and graph that on my graph so we can try to see where the two perpendicular bisectors intersect. I've drawn my perpendicular bisector on my graph, and I now know that my circumcenter is where those two perpendicular bisectors intersect. And it's not a neat point at all, so you're going to have to use algebra. You're going to have to equate this equation with this equation and see when they are equal. You're going to use algebra and find out when these two perpendicular bisectors equal each other, and that should give you a point which matches up with the point on our graph. So I've equated the two perpendicular bisectors. It means I've made them equal to each other. I've moved the x's to one side, the non-x's to the other side. I have to work with fractions, and I would like you to try this yourself. And when you get to the end, you should get that x simplifies to 5 over 9. And 5 over 9 is about 0.5 for your x. And we can see that that x is at about 0.5. It's somewhere between 0 and 1. Now we're going to sub my x in to the y, x in so we can find the y. So I can pick either this one or this one. I'm going to pick the one that doesn't have any fractions in it. I'm going to do that algebra and find the y, and then I'll have the x and y for the circumcenter. So I've gone ahead and done that. I've entered the x into the equation, and I've gotten that y is equal to negative 11 over 18, which again makes sense. That's also, again, like negative 0.6 or something like that, and that makes sense. Again, we can see that our dot is not all the way down to negative 1, somewhere not that low, so negative 11 over 18 makes total sense. And that, my friends, this x and this y together in a coordinate, that would be the circumcenter.